All right, today we're going to continue on with this chapter. Remember, this chapter is for HL only. So if you are an SL student, you don't need to watch this. This is for HLs. We're going to talk a little bit more about integrating by substitution, particularly U substitution. And the question comes up, if I'm using that technique, what should I allow U to equal? What should that function U be equal to? So I'm going to give you some tips, and then I'm going to go over a couple of examples of some of them. If you ever see the square root of a function, then U should be that function that's underneath the square root. That's my first tip for you. If you see natural log of x somewhere in that function, then you should let U equal the natural log of x. If you see the square root of a squared minus x squared, then you should let x equal a times the sine of theta, and then you're going to find dx d theta in order to complete the problem. If you see x squared plus a squared, or the square root of that, then you're going to let x equal a times the tangent of theta, and again you're going to have to find dx d theta. And then the last one, if you see the square root of x squared minus a squared, you're going to let x equal a times the secant of theta. And again, you're going to have to find dx d theta to continue on with that question. So those are 5 tips that you can use. I'm going to give you an example of the first one and an example of the last one just to see why those are good substitutions. So the first one, I've got the square root of x times, or sorry, just x times the square root of x plus 3. So remember, I said whatever's under the square root is what U is going to equal. So U will equal x plus 3, and that means that du dx is going to equal 1 because that's the derivative of x plus 3. And that means that du is equal to dx if I just cross multiply. So making that substitution, remember, x plus 3 will now be replaced with u, dx will be replaced with du, but this x has to be replaced with something. Well, that's kind of easy to figure out, because if u is equal to x plus 3, then x would equal u minus 3. So I make all of those substitutions, and this is what I end up with. U minus 3 times the square root of u du. All right, and then I can distribute that u to the 1/2 into the parentheses, and I will get u to the 3/2 minus 3u to the 1/2. And that is something I can take the antiderivative of, and that ends up being 2/5 times u to the 5/2 minus 2 times u to the 3/2 plus c. I'm not quite done yet because my antiderivative, or my integral, is still in terms of u. So I've got to convert it back to x. So all those u's just need to be changed back to x plus 3's, and then I have my answer. 2/5 times x plus 3 to the 5/2 minus 2 times x plus 3 to the 3/2 plus c. So that's an example of the first kind. Now let's talk about an example that looks like this. The antiderivative, or the integral, of the square root of x squared minus 16 all over x. So remember, what I'm going to do is I'm going to let x equal a times the secant of theta. In this case, that's going to be 4 times the secant of theta. If I take the derivative of that, that's going to be 4 times the tangent of theta times the secant of theta. And then just moving the d theta over to the other side, I get that dx is 4 times the tangent of theta times the secant of theta d theta. So now this x is going to be replaced with 4 secant theta, this x is going to be replaced with 4 secant theta, and this dx is going to be replaced with 4 times the tangent of theta times the secant of theta d theta. So let's see what that looks like. All right, so that's what it looks like when I make all of those substitutions, just like I said. I notice in the top that I've got a square root of 16 that is common to both terms. So I'm going to factor that out as the square root of 16, or just 4. And so that's what it looks like. I also notice a couple of things. First of all, I notice that this secant squared minus 1 is part of one of those Pythagorean identities, and I can change that to tangent squared. I also notice that I've got a secant theta Well, a 4 secant theta here and here that I can divide out of top and bottom. And so I'm left with 4 times the square root of tangent squared times just tangent. Well, the square root of tangent squared is just tangent, and if I multiply that by another tangent, I get tangent squared. And I don't happen to know what the antiderivative of tangent squared is, so I have to use that same identity that I used before and say that this is 4 times the antiderivative of secant squared minus 1. I do that because I know what the antiderivative of secant squared, and I do know what the antiderivative of 1 is. So the antiderivative of secant squared is just tangent, and the antiderivative of 1 is just theta, and both of those get multiplied by 4, and I do not forget to add my c onto the end. The problem is, now I have my antiderivative in terms of theta instead of in terms of x. So now I've got to go back and talk about this in terms of x. Remember, x is equal to 4 times the secant of theta, which means if I divide both sides by 4, x over 4 is the secant of theta. And if I flip that upside down, I will get cosine of theta. So 4 over x is the cosine of theta, meaning that theta is the arc cosine of 4 over x. So now I have theta equaling something in terms of x. That was the answer that I got on the previous slide. So making those adjustments, that's what I get. 4 times the tangent of the arc cosine of 4 over x minus 4 times the arc cosine of 4 over x plus c. This first term I can simplify. I can just make a right triangle and quickly figure out that the tangent of the arc cosine of 4 over x is going to equal the square root of x squared minus 4 over 4. And that still gets multiplied by 4. The rest of it I'm going to leave the same, and the only thing I really need to simplify is this 4 and this 4 can cancel. And then I've got my answer. So a very complicated example, but it would have been a lot more complicated if I didn't know the right substitution to make. So that is more on U substitution. If you have any questions, let me know, and I will see you tomorrow.